Turn left at the bakery. I know this route by heart. Don't check the map.
The bakery moved last spring. That corner's an empty lot now. You just walked us 10 minutes the wrong way.
But I was sure. It felt right.
It felt right because you didn't think. You cached. Your memory handed you an old answer instead of checking. And that exact trick and that exact bug is running inside every app you touch. Let me show you. This is Sticks It Out.
Memory never lies.
Here's the one-sentence version. A cache is a small, fast copy of an answer that's slow to get, kept close by so you don't have to go get it again every time. Have you ever noticed? You don't sound out your best friend's name letter by letter. It's cached. Instant.
Then cache everything. Keep every answer forever. Problem solved. You're welcome.
That's the naive fix, and it fails 3 different ways. The cache is tiny. The cache goes stale. And there's never just one. Watch all 3 break, and you'll finally understand why your app keeps showing you the old version. Let's start with why a cache exists at all. Some answers are slow to get. For example, one trip to the database might take 200 milliseconds. The same answer from a cache might come back in around 0.2 of a millisecond. Same answer, 1,000 times faster. So the first time you ask, you pay full price. You walk all the way to the slow vault, get the answer, and on the way back, you keep a copy on your desk. That trip is called a cache miss. The answer wasn't on the desk, so you go fetch it and store it. The second time you ask, the answer is already on the desk. That's called a cache hit. Basically free, no trip.
So a cache is just a copy? I leave myself notes all the time. That's not clever.
The copy isn't the clever part. It's where you keep it. Somewhere fast to reach, and that you skip the slow trip entirely. A copy in a slow place saves you nothing. A copy on the desk saves you the walk. But that desk only has limited room. You can't keep every answer you've ever fetched. So something has to go. What do you throw away? Now let's get back to your brain. It can't keep everything ready at your fingertips. A few things come to you instantly. Everything else takes real effort to dig up, or it's just gone. You rattle off your childhood phone number without thinking, but you can't find the coffee you set down 2 minutes ago.
That's just me being bad at coffee.
That's your cache doing its job. It keeps what you use and drops what you don't touch. The number got dialed 1,000 times. The coffee cup got 1 glance. When the shelf is full, the coldest thing, the one you haven't reached for in the longest, falls off the edge. That's eviction. To keep this simple, we'll use one rule for what to drop. Throw out whatever you haven't touched in the longest time. It has a name, least recently used. It's not the only rule though. Some caches drop what gets used the least, some drop the oldest, some just pick at random. Same idea every time. When it's full, something has to go.
Fine, make the shelf bigger, buy more memory.
Then it stops being a cache. Make it big enough to hold everything, and you've just built a second slow copy of the whole database, paying to store it all twice, and it gets slow to search too. A cache is useful because it's small. Small means it holds only the hot stuff, the small slice you actually use. But forgetting isn't the scary part. The scary part is when the cache remembers, and it's wrong. Picture your favorite coffee shop. You walk there on autopilot, except it closed 6 months ago. Your memory was a snapshot, perfectly right the day you took it, and dead wrong now because the world moved and nobody updated your head. A cache is a snapshot too. The moment the source changes, every copy of it becomes a quiet little lie. That's your app showing the old version. The real data changed. The cached copy didn't get the memo.
So check if it changed before you trust the copy. Easy.
Check with what? Walking to the source to ask, are you still the same, is the exact slow trip the cache was supposed to save. Do that every time and you've deleted the whole point. So you don't check, you guess. You keep the copy for a set time, then throw it out and go get it fresh. That timer is called the TTL, time to live. Too long and people stare at old data. Too short and you're back to making the slow trip constantly. There's no perfect number. You're placing a bet. A timer is just the simplest way to picture it. Smarter systems don't wait for the clock. They throw the copy out the moment the real data changes. Same bet. They just call it sooner. Your processor keeps the last few things it used on a tiny chip so it doesn't wait on memory. Memory keeps a copy of what's on the slow disk. Your browser keeps a copy of images so it doesn't re-download them. A CDN keeps a copy of the site near you so it doesn't cross an ocean. And the server keeps the last database answer in memory so it doesn't rerun the query. Every one of those is a cache of the layer below it. And each layer down is slower than the one above, usually by a lot. That growing gap is the whole reason the stack exists.
So the app I'm using is lying to me at, what, 5 different levels?
It's showing you the closest copy it still trusts. That's not lying. That's the only way it's fast enough for you to stand using. Same 3 rules at every single layer. Answer's there, it's fast. Shelf's full, drop the coldest thing. Copy's too old, throw it out. Remember the sticky note on the desk, the shelf that dropped your keys, the closed coffee shop? That same story plays out, top to bottom. The whole thing, interview version. A cache is a small, fast copy of an answer that's slow to get. You keep it because fetching it again takes time. It's small, so it drops what you don't use. It's a snapshot, so it goes stale, and you bet on a timer. And it's never one cache, it's layers, from the chip in your hand to a database across the country. This week, find one spot in your code that fetches or computes the same thing with the same input over and over. That's a cache waiting to happen. And the next time you see old data, don't blame the database. Ask which cache is lying to you. There's an old joke. The 2 hardest problems in computer science are naming things and knowing when to throw a cached copy away. And here's the way it really bites. Picture one copy that thousands of people are using at once. Its timer runs out. And at that exact moment, every one of them misses together, and they all rush to the source at the same time. The database the cache was shielding gets buried under the traffic it was supposed to soak up. That's a cache stampede. The fix isn't a bigger cache. It's making those misses line up and share one trip instead of all charging at once.
Simple. Set every TTL to forever. Never expires, never stampedes.
That's how you end up walking to a coffee shop that closed in 2019. Which copy to throw out first? That turns out to be its own science, and least recently used is only where it starts. That's the next video. This has been Sticks It Out. Don't let your brain deploy on a Friday.